So guys, let's move on to fourth episode of DSA Python series. The question says given an array nums sorted in non-decreasing order. So the array is sorted. This is given. We have to remove the duplicates in place. It means that we don't have to create another array and we just have to rearrange or remove the duplicates from the same array. Alright. And one more thing is given, relative order of elements should also be kept same. Consider the number of unique elements in nums to be k. So this we have to consider it as k. After removing duplicates, return the number of unique elements k. So we have to return the number of unique elements k. So this is the further information given. The first k elements of nums should contain the unique numbers in sorted order. Remaining elements beyond index k-1 can be ignored. So after k-1 you can have any elements, that doesn't matter. So if this is the example given, if input num is 1 1 2, the output should be 2 because our array will become like this. Okay, 1 2 and any number of element may come, but our primary focus is to have unique elements initially. So explanation is also given. Your function should return k equals 2 with the first two elements of the nums being 1 and 2 respectively. It doesn't matter what you leave beyond the returned k, hence they are underscores. Alright, so what is the intuition which is coming? What is the intuition? I am given the sorted array, right? So we don't have to sort it again, and the array is not a random array. We have to return k elements which are unique. So how will be my brute force approach? Brute force will necessarily involve for loop. Discuss what will be the brute force. So we assign n equals length of nums and assume one frequency map. This will be empty dictionary. Then let us iterate through the loop for I in range 0 to n. Okay, we have n already, we have provided through length of nums. So what will be n? 1 2 3 4 5 6 7 8 9 10 11 12. So the value stored will be 12. Okay, we will basically create a dictionary. How that will be created? We have to iterate through this loop, and we will this nums of I into frequency map this dictionary. Okay, so frequency map of nums of I. Okay, so this is key and this will be value 0. Okay, so as it iterates through this nums, it will see, so this is 0, so 0, it will be 0, then next is 0, so frequency map of 0 will again be 0, so it will not change. Then next I will come here, so frequency map of nums of I. So nums of I means nums of 2, right? So this is 0 1 2 3 4 5 6 7 8 9 10 11. These are the indexes. So nums of 2 will be 1. So frequency map of 1 is equal to 0. So this will get updated. Similarly, when it goes here, again there is 1, so it will remain the same. Again this I goes to index number 4, so nums of 4, it will be 2, so how it will be? 2 is to 0. So this is how the dictionary will get created. 3, then 4, then 5, then 6. Okay, now we will iterate through this. Iterate through this dictionary. So for j in frequency map, right? So we will assume the initial value of j equals 0. So basically we will iterate through key. Okay, so we will assume key as k. So for k in frequency map, so it will iterate through here. Okay, and here we have assumed j equals 0, so we will start like this. Nums of j is equal to k. So the k assumes the value of 0, 1, 2, 3. So what we are doing is we are putting these values in nums of j. That means it will update like this. So 0 will come here, then 1 will come here, so it will overwrite. 2 will come here, okay, then 3, then 4, then 5, then 6, right? So this is how it will be created, and the rest we will keep as it is, so it doesn't matter. And we have to basically return the value of j. Okay, so we have to increase also the value of j such that it iterates through the keys, right? In the end we will return j. So this is the brute force approach. Now let us do the optimal approach, how we can do. Now let us think about optimal approach, how we can do it. So before going to optimal approach, let us find out the time complexity. So time complexity for this loop will be order of n, right? And for these it will be order of 1, right? Also for frequency map, picking the values will attract order of 1 as the time complexity. So the overall time complexity of the code will be order of n. What will be the space complexity? Space complexity will be order of k. Now let's talk about how will be optimal approach. What will be optimal approach? So our array is 4, 5, 5, 5, 6. Okay, let's say this is our array. So in two pointers approach we will put our ith element as here and j at I plus 1. Okay, so we will first assume I is equal to 0, I in range 0 to n. Okay, we will check if nums of I is not equal to nums of j. Let's say we assume this situation, our j is here. So when nums of I, that is 0, is not equal to nums of j, right? So this condition is true. So what we will do, we will this position, and what we will do, we will swap j and I. Okay, so we will swap this number. Okay, we will write the condition if nums of I is not equal to nums of j, right? What we will do, we will do I plus equals 1 and we will swap, or we will just assign nums of I is equal to nums of j. We will always be doing j plus equals 1, and in the end we will return I plus 1. So every time I will be at one position lesser than j, and j will be at the last position of the complete array, which will be unique array which will be created. So we have to just increase 1 on this ith element. So this is the most optimal solution. Okay, now let us talk about the time complexity. Time complexity will be, this is the order of n. Okay, this is assignment, so it will have order of 1. This is the condition, this has the order of 1, here also order of 1, and so we have the time complexity as order of n. What is the space complexity? Are you taking any extra space? No. So the space complexity will be order of 1. Okay, so this is how we can remove the duplicates from any given sorted array with this optimal and brute force approach, right? So guys, keep watching this and keep learning DSA for cracking FANG and other companies.